Hello friends, myself R.D. Mahajan presenting my video on vector calculus revision part 3. Example, verify Green's theorem for line integral of xy plus y square into dx plus x square into dy over curve C, where C is bounded by two curves y equal to x and y equal to x square. Therefore, the first step is to draw that figure. Therefore, y equal to x, a straight line passing through origin, and y equal to x square, a parabola symmetrical to y axis. 2 point of intersections. One is y equal point of intersection for that two curves, y equal to x and y equal to x square. We get x square equal to x, means x square minus x equal to 0. Taking x common, we get x minus 1. Therefore, x equal to 0, 1 point, and second point is x is equal to 1. And therefore, when we put x is equal to 0, we get y equal to 0. And when we put x is equal to 1, we get y is equal to 1. Therefore, the points are 0, 0 and 1, 1. Join that 2 points, we get a straight line, y is equal to x. By Green's theorem, we have this line integration of m dx plus n dy over C, curve C, is equals to double integration of dou n by dou x minus dou m by dou y with respect to xy over that closed region R. This is the statement of that Green's theorem, and therefore to verify it, we require to find out left hand side and value of right hand side, and if that two values are equal, we can say that theorem is verified. Here, that m dx plus n dy, m dx plus n dy is equal to xy plus y square into dx and plus x square into dy. Comparing these two sides, therefore we get the value of m as xy plus y square and the value of n as x square. Then line integration of that m dx plus n dy over curve C is nothing but line integration of xy plus y square dx and plus x square dy over curve C. It is sum of two line integrals, and therefore it is line integration over the path OA and plus line integration of over the path AO, and we call this equation 1. Therefore, we require to find out these two values separately. Therefore, along AO, OA, equation of that curve is y equal to x square. Differentiating it with respect to x, therefore we get dy is equal to 2x dx. Substituting that values here, we get therefore that line integration of xy plus y square dx plus x square dy over the path OA is equal to integration of x into y is x square, therefore x into y is x square plus y square, square of this we get x raised to 4 into dx, as it is no change, plus x square dy dy is 2x dx, means converting in terms of x. And then as we have to integrate it with respect to x, see how x varies over this path OA. It is from 0 to 1. Therefore, x is equal to 0 to x is equal to 1. And then simplifying it, we get integration from 0 to 1, x cube plus 2x cube. This x cube plus this 2x cube, we get 3x cube, and this x is to 4. And its integration with respect to x. Performing integration, we get 3x is to 4 by 4 and plus x is to 5 by 5, and limit from 0 to 1. Substituting upper and lower limit. For upper limit it becomes 3 by 4 plus 1 by 5 5 is a 15, 15 plus 4, 19, 19 by 20. That is the value. We call this equation 2. Value of the first line integral over the path OA. Then we try to determine over the path AO. Along that path AO, it is a straight line whose equation is y equal to x. Differentiating it with respect to x, we get dy equal to dx. And therefore, that line integration of xy plus y square dx plus x square dy over the path AO is equals to substituting values. Therefore, it is integration of x into y, y is x, therefore it becomes x into x, x square, plus y square means again x square dx, plus x square and dy, dy is dx. And as we have to integrate with respect to x, see how x varies here over that path. It is from 1 to 0. Therefore, 1 to 0. We get integration from 1 to 0. X square plus x square plus x square. We get 3 times x square. And its integration with respect to x. 3 constant outside. Integration of x square is x cube by 3. And limits from 0 to 1. 3 get cancelled. Limit from 1 to 0. Substituting upper and lower limit. Upper limit it is 0. Lower limit is 1. 1 cube is 1. 0 minus 1. We get that value as minus 1. Equation number 3. Substituting that two values here, we get that value of left hand side. Left hand side LHS, a line integration of xy plus y square into dx plus x square into dy over that curve C, as along OA the value is 19 by 20 and along AO it is minus 1. Finding LCM, we get it is 19 minus 20 divided by 20, and therefore the value is minus 1 by 20. Value of the left hand side, value of that line integral. Then we require to find out the value of right hand side term by performing this double integration. In right hand side term, we require that two partial derivatives, dou m by dou x, dou m by dou y and dou n by dou x. M is a function of x and y, therefore differentiating it with respect to x, with respect to y, keeping x constant, Therefore, derivative of this term with respect to y is x, and derivative of y square is 2y. Differentiating n with respect to x, keeping y constant. Here it is function of x only. Therefore, its derivative is 2x. And then finding that value of dou n by dou x minus dou m by dou y. Dou n by dou x is 2x minus x plus 2y. Therefore, 2x minus x, we get x, and minus 2y. And therefore, that right hand side term is double integration of dou n by dou x minus dou m by dou y. Value is x minus 2y, and its integration with respect to xy over that closed region R. Here in this region I have shown the strip, elementary strip parallel to y-axis, and as per that strip your first integration is with respect to y. Therefore, x minus 2y, we have to integrate with respect to y and then with respect to x. Limits for y, lower end lies on the curve y equal to x square, upper end lies on that line y equal to x, and then moving that strip throughout that region from this line, y-axis means x is equal to 0, to this line x is equal to 1, and then performing that integration we get outer integral as it is, no change, integration from 0 to 1. Integrating this with respect to y, it is xy minus 2 times integration of y is y square by 2, and limit from x square to x, and its integration with respect to x, integration from 0 to 1, substitute upper and lower limit for y, therefore outer term x as it is, no change, y is x minus lower limit x square, 2 get cancelled, minus y square, upper limit square, that is x square, minus lower limit x square and its square, that become x raised to 4. Its integration with respect to x, and therefore simplifying it we get integration from 0 to 1, x into x we get x square, minus x square get cancelled, x square minus x square get cancelled, this one is minus minus plus, x raised to 4, and minus this x cube. Integrating this two term with respect to x, integration of x raised to 4 is x raised to 5 by 5, minus integration of x cube is x raised to 4 by 4, limit from 0 to 1. Therefore, substituting upper limit and minus lower limit. For upper limit it is 1 by 5 minus 1 by 4, and for lower limit it is 0 minus 0, we get 0. And then simplifying it, we get that value as cross multiply, it is 4 minus 5 divided by 5 4s are 20, and therefore value is minus 1 by 20. Equation number 4. Value of RHS, and if you see the values of LHS and RHS, both the values are same, means theorem is verified. Value of left hand side is minus 1 by 20, and value of right hand side is also minus 1 by 20. as values are same, therefore theorem is verified. Green's theorem is verified. One problem of Green's theorem, how we can verify that Green's theorem. If you like my video, please share it, as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.